I is equal to integration of log of x divided by x into 1 minus log of x into 2 plus log of. As you can observe here, the denominator is in factorized in term of log of x. As we know, if integral containing log of x, we have to substitute evaluate integration by substitution method. So we put log of x as a t and differentiate with respect to x. Derivative of log of x is 1 upon x into dx, as it is term of x, and derivative of t is dt. Now you can observe in integral dx has a multiplier 1 upon x, so we can easily substitute it, and log of x is substituted in term of t. So I will become, as the log of x is in numerator, so we put first t in numerator, and in denominator the term of log of x are in product in bracket. So in first bracket we get 1 minus t, and in second bracket we get 2 plus t, and 1 upon x dx is a dt. So substitution is completed. Now observe this integral, as this is again integral with containing rational fraction with factorized denominator, as there are two factors in denominator. So here we take a fraction out of integral, that is t divided by 1 minus t into 2 plus t. As these are two linear factors, so we can take partial fractions using two unknown constants. First was a divided by first linear factor 1 minus t, plus second is a b divided by second linear factor 2 plus t. Now multiplying both sides by denominator of left hand side, so we get t is equal to a is multiplied by 2 plus t, and plus b is multiplied by 1 minus t. Put it as 1. Now taking the values of t, we get the unknown constant a and b. First, to evaluate a, we take the value of b t such that term of b is going to 0, so that we take it as a 1. So put t is a 1. On left hand side we get 1 is equal to a into bracket 1 plus 2 plus 1 plus term of b eliminated. So 1 is equal to 3a, so a is a 1 by 3. Now similarly we take the value of t, so that term of b a eliminated. Now taking the value of t as a minus 2 here, put t is equal to minus 2. On left hand side we get minus 2, term of a will become 0. So in term of b, in first in bracket 1 minus 2 here. Okay, so minus 2 is equal to minus plus 2, 2 plus 1 3, 3 into b 3b, so b is a minus 2 upon 3. So required fraction is, as a is a 1 by 3 divided by first linear factor 1 minus t, plus constant b is a minus 2 by 3 divided by second linear factor 2 plus t. Now take integration with respect to t on both sides. On left hand side we get integration of t divided by 1 minus t into 2 plus t dt. On right hand side there is a addition, so we take separate integration. In first integration 1 by 3 is a constant, so in integration we get 1 upon 1 minus t dt, and minus 2 by 3 is a constant in second integration. In integration we get 1 upon 2 plus t dt. Now left hand side integration is generated by I, so I is equal to 1 by 3. Now here is a linear term of t in denominator, as coefficient of t is here minus 1, so its integration will be log of linear term 1 minus t divided by minus 1, minus 2 by 3 into here, this is linear term with coefficient has t has a 1, so its integration will be log of 2 plus t and plus c, and finally we resubstitute the value of t as log of x, so we get the answer 1 by 3. Actually this minus came into numerator, minus 1 by 3 log of 1 minus log of x minus 2 by 3 into log of 2 plus log of x, and plus c is our constant. Similarly, there are number of examples which can you solved by using substitution and partial fraction. The example like sec square x divided by 1 plus tan of x into 2 plus tan of x, or integration of cos x divided by 2 plus sin x into 3 plus sine of x into dx, which are important example. As you can observe here in denominator there is a product, that means the denominator is a factorized. Now in first example, factorized in term of tan of x, as derivative of tan of x is a sec square x contained in integral, so you can put the tan of x here, and then you get a rational fraction which can be partial, which we can partial fraction. In second example, as denominator is factors of in term of sin x, so derivative of sin x is cos x containing integral. So you can solve this again by substitution and get a rational fraction which can be partialized to evaluate integration. I is equal to integration of x divided by x square plus 1 into x square plus 2. As denominator is a factorized in a polynomial of quadratic polynomial of x, but you can observe here in both factors we have term of x square, as derivative of x square is a 2x. So in this example, by using by taking direct partial fraction and to solve to evaluate the integration, instead of that we use substitution method and put as x square is equal to t, and we differentiate this with respect to x, we get 2x dx is equal to dt. As we observe the integral, we have to adjust relation between dx by dt, as dx has only term x in multiplication, so we get x dx is equal to dt divided by 2. So integration I will become, as we put x square in denominator, so we take numerator as a 1, and in denominator first term will be t plus 1 and second term will be t plus 2, and x into dx is replaced by dt by 2. As 2 is a constant, we take it outside integration, so we get 1 by 2 into integration of 1 upon t plus 1 into t plus 2 dt. Now you get the rational fraction in an integral which we have to partialize. So here the fraction is 1 upon t plus 1 into t plus 2. As denominator is contain two linear factors, so we get two partials with two unknown constants, as a first partial is a divided by t plus 1 and second partial will be b divided by t plus 2. Now multiplying both sides by denominator of left hand side, we get the equation 1 is equal to a into bracket t plus 2 plus b into bracket t plus 1. By putting the value of t is equal to first minus 1, as b term of b becomes 0, so 1 is equal to a into bracket minus 1 plus 2, so we get minus 1 plus 2 plus 1, that is 1 is equal to a, or a is equal to 1. Similarly, putting t is equal to minus 2 to eliminate the term of a, we get in equation 1 is equal to term of a will be 0 and b in contain in bracket minus 2 plus 1. So minus 2 plus 1 is minus b, as minus 1 into b minus b, so b is equal to minus 1. So we get required partial fraction as 1 upon t plus 1 into t plus 2 is equal to 1 upon first linear factor t plus 1 plus b is equal to minus 1 upon second linear factor t plus 2. Now take integration on both sides to evaluate integration. So on integration, on left hand side 1 upon t plus 1 into t plus 2 dt is equal to the integration of first term t plus 1 dt plus integration of second term minus 1 upon t plus 2. Now observe this, as we have in integration I is equal to 1/2 into integration of rational fraction. We are taking here integration of rational fraction, so we can't put I on left hand side here now. So we take only integration on right hand side, which is a log of t plus 1, as these are the linear terms in denominator, and in second minus log of t plus 2. Now don't put the value of integration constant c, as we put it at end of the example always. So now we get I is equal to, now putting integration of this fraction in I, we get 1/2 into bracket, as there is addition log of t plus 1 minus log of t plus 2, and finally we take substitution of value of t. So I is equal to 1/2 into bracket log of value of t is x square plus 1 minus log of x square plus 2, and bracket complete, we put the constant of integration c.